Hey everybody, and welcome back to Jim's Garage. This is the first of two videos that are going to focus on logging and monitoring. This first video, I'm going to walk you through all of the tools that you're going to require and how to configure and deploy those. In the second video, we're going to look at how you actually configure and use those tools. So by the end of this video, we'll have things like Grafana, InfluxDB, Prometheus, Telegraf, and a couple of other freebies all set up within our environment. In the second video, I'll show you how to plug those in so that we can monitor things like Docker or CrowdSec or pretty much anything that is able to spit out a log or has access to a metrics API. This is going to give you all of the fundamentals you need to then happily go off and monitor and alert on basically anything you want to. So we've touched a little bit on logging and monitoring already in this series. Things like our traffic logs, which we set up so that we could use things like Authelia, or things like CrowdSec, both of which require access to logs. Now, the monitoring part which we're covering today kind of sits in the middle of the sandwich. So at the bottom, you've first got to enable your logging, and then you want to do some monitoring of those logs, because there's little point in just doing logging if you're not going to monitor them. And the top part, the next bit of bread in the sandwich, that would be your alerting. So a bit like in my world where we have security operations centers, you would parse your logs, you would monitor those, and then you would set up alerts based on thresholds. And what you're going to learn in the next couple of videos is applicable to pretty much any IT tech job and also other walks of life outside of technology. Things like a call center, for example, you'd want to monitor and record your call efficiency, how long it's taken to do a call, all of those sorts of things. In an IT operations world, you'd be concerned on uptime, availability, those sorts of things. And importantly, you want to be alerted when something goes outside of your threshold. Let's say your servers are using more than 80% CPU. That's either indicative of something going wrong, or maybe you need to expand and upscale your environment. So as always, in these videos, I'm going to show you all of the configs. We'll walk through them step by step. I'll explain what each of the tools does and why we've configured it in such a way. I'll show you how to deploy that within Docker, and handily, all of these scripts are going to be available on my GitHub, and it's a single multi-container Docker Compose file. So really simple to deploy this. We just need to do a few config tweaks and we'll be up and running. So let's do a feature overview of some of the tools, and then we're going to dive into configuration. So the first tool, and probably the one that you're already familiar with, even if you're not familiar with logging and monitoring in general, is Grafana. Now, Grafana has exploded over the years, and it's an open source logging and monitoring tool. And it's pretty much the glue that's going to bind everything together. So Grafana by itself isn't going to be doing the recording or the collection of our metrics. No, what it's going to be doing is bringing that all together so that you can do queries based upon other data sets or metric scrapers. And it then gives you the ability to present this in really handy dashboards that are highly customizable. There are tons of native panels. Those are the things that you put into the dashboard. These are things like graphs, pie charts, histograms, etc. And it's fully extensible, so you can even write your own if you wish. Now, because this is Homelab, we're going to be setting this up on our own infrastructure. But do be aware that there is a Grafana cloud, which is free. There are some constraints on that, usually around the amount of traffic and data retention, but that might be something that you want to consider, and you can see the link here. So touching on a couple of points I just made, if we head over to something like the dashboards, you get an example of what this looks like. So here we can see a number of dashboards that are logging and monitoring various things on a system. We can have a look at a demo here. For example, this is looking at Jira tickets, something we all spend too much time monitoring, or it could be something like a MongoDB. And as a quick spoiler, here's the dashboard that we'll be setting up later in the video series. This, as you can tell, is monitoring my Docker containers. So you can see CPU usage, memory usage, disk usage, network usage at the per container level. So this is useful for keeping tabs on containers, understanding how your resources are being utilized, and maybe you want to put some constraints on them, or revisit in terms of if there are any problems, i.e. you're seeing excessive disk usage when you know that container shouldn't be doing anything. Moving on from Grafana, which is our primary dashboard for graphing all of our data, we get onto what I call the backend services, which are the metrics collections. And the first one of those is going to be InfluxDB, Influx database. And the clue's in the title, it's all about time. So this is probably the most performant time-based metric collection database, and it's great for just hammering loads of time-based data into a database really quickly. And this is used at scale for some of the biggest organizations you can think of. And handily, InfluxDB has its own web GUI, so you could actually use this to do some graphing, but we're going to leave that to Grafana. And as I showed you the Docker dashboard, that's actually plug-ined back-end to this InfluxDB that you can see on screen, and you can see lots of handy things, so like Docker, memory total for my Ubuntu machine, and there's a value here, and you could graph that. And that's exactly what Grafana is doing. I have it connected to this InfluxDB, which is scraping the metrics from my Docker host, and is presenting that in the nice Grafana dashboard. And in this video, we will be deploying InfluxDB, and in the subsequent video, I'm going to show you how to configure it to do that scraping so that we can pull it into Grafana. Moving on to the next product in our stack is Telegraf. Now, the eagle-eyed among you will notice that this is actually owned by Influx Data, so you'll be asking the question, what's the difference between InfluxDB and Telegraf? Now, InfluxDB, the clue's in the title, is the actual database, and some applications can directly write to it. However, there's a number of applications that don't have that capability, and so Telegraf is a separate component that will collect those metrics for you and then import them into InfluxDB or any other data store that you want to use. It doesn't have to be InfluxDB. It could be Prometheus, for example. So I use Telegraf in my Homelab to get metrics from Sophos XG into Grafana. Now, Sophos XG doesn't have a native way of pushing that data into a database, which Grafana can use. Instead, it opens up a metrics API. Telegraf can connect to that API and store that data in Influx. I can then use the data in Influx to create a Grafana dashboard. So I hope that spells it out for you. There are applications that can natively store straight into a database, but for all those that can't, or anything you're doing custom on your Homelab, you might need something like Telegraf to do it for you. One other application that I've included in the stack is Graphite. Now, we're not actually going to be using this in the second video, but do note that it exists. It's one of the big players, and it might have some features over the others that we're going to deploy that might make it more attuned to what you're trying to accomplish. As you can see, Graphite is used by some of the biggest players in the game: Reddit, Salesforce, Booking.com, Etsy, GitHub. You get the idea. Its USP is for storing numeric time series data, a bit like InfluxDB, and to render graphs of this data on demand. So I'll provide a config to set this up. We're not actually going to use it, but it might be useful for you to have, and you can simply comment this out or delete it if you don't want to deploy it. The final application that we're actually going to deploy and make use of is Prometheus, and this is a big player in the area of monitoring and alerting, and that's kind of where it excels. As it says, it's the leading open source provider for alerting, and that's pretty much what we're going to be using it for. So you can store data in here, but typically it's more for queries and setting up alerts so that we can use Telegraf to scrape our metrics, we can store that into a database, we can deploy Grafana to then use it and dashboard it, and then we can set up alerts using something like Prometheus. A couple of other extras that I'm throwing into the Compose stack are Promtail and Loki. Now these are part of the Grafana suite, and they're typically around scraping and storing log files. So a bit like applications that might not have a mechanism to export directly to a database, Promtail, and the clue being tail, we've tailed logs before, it can take those log files, it can store them, it can then parse them and then store them into a database so that we could do Grafana dashboarding off some of those queries. So I appreciate a lot of this is getting quite complicated, but it's just another way to pick up a log file, store it somewhere, do some queries on it, and then create a dashboard out of it. So congratulations if you've made it through my explanation, and hopefully your head hasn't exploded. There'll be a lot of new concepts in there if you're new to logging and monitoring, but hopefully I've tried to break it down into some simple steps. And even better, I've put this into a single Docker Compose file. So this is available on my GitHub. Let's have a look through each of those applications now and see what's going on in there in terms of the config files. So Loki sits in front of Promtail in a way. So as I mentioned, we've got Promtail here, and that's for storing the logs for our services. Loki, on the other hand, is for querying those logs and being able to pump that data out so that something like Grafana could use it. So Loki is pretty straightforward. It needs a simple volume mount and it requires a port to access it. That's it. You'll want to make sure that any customization to the config file is done within that volume mount, because it's subsequently picked up here where it stipulates where the config file is mounted. Moving on to Promtail, this version on here will deploy Promtail, and because of the volume mount, it will actually take the system logs on your Docker host or whatever machine you're running it on. So that means you could get all of the system logs that are going on, so things like access, login, all those sorts of things. You would then be able to parse those with Loki and create a dashboard out of that using Grafana. Next, we get onto Grafana itself. Now, this is the front end and where we're going to be doing most of our monitoring. And again, it's pretty straightforward. We're simply going to pull the container. We're going to put it on some internal and external networks. So I've set up the Grafana monitoring network, which all of these services are connected to, so they can talk to each other using friendly DNS names, and they're not going to be accessible outside of our network to things that we don't want to be able to access them. The ones where I've added a port are obviously available externally. Because we can put this through our reverse proxy and get the benefits of SSL encryption, etc., I've included the traffic labels here. Next up is InfluxDB, and again, this is pretty straightforward. It just requires a couple of ports to be open and a volume mount to store all of your data within your Influx database. Next is Telegraf, and there's only one thing here really we need to focus on, and that is the user. In older versions of Telegraf, you could simply run this as your local or root user, but that's changed in an effort to improve some of the security. So you need to find out the global ID of your Docker user if you've not added Docker to your sudo group, and just specify it here. Now, I've added some additional volume mounts here, and you can remove those if they're not applicable. The one that you're probably most interested in is the Docker SOC, and we've used that before, namely in Portainer, where it's able to have access to the whole Docker runtime environment and actually spin up and edit containers, dive into them, etc. And that's because it has access to the Docker SOC. So because we want to monitor the Docker containers on our host, we add the Docker SOC here, and that enables Telegraf then to go and scrape some of that data. Next up is Graphite. That's pretty straightforward again. There's a number of ports depending on what services you want to run on Graphite or what you want it to be used for. And there's a few volume mounts here, but chiefly it's for your configuration files and your data storage. Lastly, we have Prometheus, and again, this is pretty straightforward. Prometheus is listening on port 9090, and we can access that as a web GUI to do queries and just to double check what it's actually scraping. But we simply need to mount a configuration file into the bind mount and then load that up. This gives us the benefit of being able to make configuration changes within a nice friendly text editor and then having those recognized within Prometheus itself. So for example, we're going to be editing the config file for Prometheus so that we can query our CrowdSec data. So having gone through all of the services we're going to run, let's get on to deployment. So heading over to my Docker VM, I've copied that compose file over. Now, obviously you can redact the services that you're not interested in, As I mentioned, in the second video, we're only going to be focusing on Grafana, Influx, Prometheus and Telegraf, so you can get rid of the other ones if you don't want them, but I've put them there primarily to make you aware that they exist and they might be useful for specific data collection that you have in mind. Now before we go ahead and deploy this, there are a couple of configuration files that we need to make first. Otherwise, it's either going to create default configuration files that won't be of use, or it's not going to be collecting some of the metrics that we want it to. Or it may even just fail saying that it couldn't find a configuration file. So let's go and rectify that now. So the key file here that we're going to want to change or create is the telegraf.conf file. Now I've put this in my Docker Grafana monitoring Telegraf folder because that's where I specified it in the bind mount. If we open up that file, I've added the basics so that you can start querying the Docker SOC. So this is the first part towards getting our Docker metrics into the Grafana dashboard. So what we've set here is that the endpoint is the Docker SOC, and you'll remember that we mounted that as a volume mount in our compose file. And we've said that we want basically all containers. We're going to include them all. We're not going to exclude any specific ones. We've said that we want it for each device. We've said that we want to include things like the CPU, and a whole host of other things which you can see in here. Things like the block IO, the input output, and networking stats. At the bottom, you'll notice here that I've actually put the outputs InfluxDB v2. Now, this is because, as I mentioned, Telegraf scrapes data and sends it. It's kind of like the postman. There's a factory that makes something, there's a postman that delivers it, and you receive it. So, for this example, we've got Docker, which Telegraf is scraping the metrics. It's then sending them, and this is where we specify the outputs. Now, just be aware that there are lots of different outputs for lots of popular data stores. This one just happens to be InfluxDB because it's pretty much the best for what we're wanting, this time series data. And you'll notice that I've got some URLs and some tokens here. You can't set this up at the moment because we haven't deployed InfluxDB. What we're going to need to do is deploy it without the output section and come back and add this in later once Influx is up and running, because you generate this token within the Influx GUI. So redact this section, I'll have it cleaned on my GitHub, and you should be good to get this up and running. We'll also need to create our Prometheus.yaml file. Now, this is the Prometheus config file, and if I open up that file, it looks like this. So all we're doing here is setting the global parameters. Now, if you didn't set this config file, it would auto-generate one, and that's fine, but we need to be able to edit it. Plus, when it comes to integrating with CrowdSec, we'll add this second section here. We'll do that in the next video. So just for this video, feel free to redact this section here and simply run it with the ones above, and feel free to tweak those as it covers things like how often it's going to scrape. That means how often it's going to go and fetch new values to put into your database. So with all of those config files configured, let's close these down. We'll head to our command line. We'll navigate to where our Docker Compose file is, and we'll simply run a sudo docker compose -d. Once that's been run, the files will download, and fingers crossed, you should be up and running. So let's go ahead and do that now. So this will take a little while to download because it's quite a few containers, but once it's done, you'll end up with something like this that says running and started. So let's go and validate that that's all working now within Portainer. Obviously, you can do this with sudo docker logs and then the container name if you're not running Portainer. So hopping into Portainer, we can see that all of the containers are up and running, and if we want to look at the published ports, we can see that over here. So we should be able to hit the VM IP and then the port to access this service. Let's have a quick look in some of the logs just to make sure things are as expected. Let's take Grafana, so heading into the Grafana logs, hopefully we can see something like this. It's up and running and it's listening on port 3000, which is the default port that Grafana runs on. So if you're not using a reverse proxy, you'll be able to go to your IP and 3000 and you should be presented with the login page. If you're running this behind a reverse proxy like Traffic, I've included the labels in the compose. You should be able to now go to your URL that you've put within your DNS resolver and access this with a friendly URL with HTTPS. Just checking some of the other services are up and running. So one of the key ones will be Telegraf. We can see that Telegraf is up and running and there are no errors in the logs here. If we head over to Prometheus, we'll also see that mine is up and running and I don't have any errors in the logs. We can see that it's listening on port 9090. So again, if we go to our Docker VM IP and port 9090, we'll be able to access the web GUI for Prometheus. So let's just go ahead and test a couple of these containers just to make sure that they're up and running. And I'll show you quickly how to connect these services together within Grafana so that in the next video, we can start to scrape and parse some of that data and start to build out some of our dashboards. So here you can see that I've got InfluxDB up and running and it's assigned to my VM IP and port 8086, which is what we exposed within the Docker Compose file. Now, if we log in with our username and password, you'll need to create this the first time you run it. You should get into the dashboard and you can have a look around. And if we log in, we should already start to see some of the Docker metrics, because if you remember in the Compose file, we mounted the Docker sock and we told it to go and start collecting some of this data. So if we click on something like the Docker container CPU, we can get the container ID. Now, these aren't very user-friendly. They will have a name assigned to them. These are just the internal reference for Docker. We click that, expand this all of the way. Unfortunately, it's hidden behind my face, but this is telling me the name of it is the Grafana monitoring container. So this ID here is basically Grafana, and you could go through and query all of these just to check that you get some data. Obviously, the best way to do this will be to use Grafana to pull these stats out and give you nice friendly names and nice friendly stats. Speaking of Grafana, let's head over to there now. As with most of my services, I run it through my reverse proxy. So in my case, it's grafana.jimsgarage.co.uk. And if I hit that, I'm going into my Grafana. Now, you might worry that I've got a not secure in the top left. That's just because I spun up a new version of Traffic that I have a separate VM for all these machines, and it's using the default certificate at the moment. But in my previous videos, I've showed you how to go and get a valid certificate. I'll fix that for the next video. So once you've created your user within Grafana, you'll be presented with the dashboard. Now, I've already showed you a few dashboards that I've got configured, and we'll be going over that in the next video. But if you want to connect some things together, you simply need to click the menu in the top left, and you need to go to Connections, which is here. Once you click Connections, you'll want to search for the things that we've set up within the Docker Compose stack. So for instance, Influx would obviously be one of them. So if we search for Influx, we would click on here, we would add a new data source, and then we'd fill in all of the details. So in this case, it would be HTTP influxdb:8086, which is what we set in the Docker Compose file. And we need to add in some API keys, which we'll do in the next video. But that's very quickly how you would connect these services, and you'll do the same thing for things like Prometheus and Telegraf. So with Prometheus, there isn't any username and password. We just simply log in, and as you can see, I have this up and running on port 9090, and we can start to query some stats here already if we configured the output in the config file. So for mine, and in the next video we'll be doing this, if we went to the status and we went to the targets, you'll see that I've got my CrowdSec specified here. So this is going away and it's pulling in the data from my CrowdSec, so I can create a dashboard. And so in the next video, I'm going to show you how to plug all of these together, how to set them up to record that data, and ultimately you're going to end up with something that looks a little bit like this. This is monitoring my CrowdSec, and if you wanted to have a look at, say, something like Docker, I also have a dashboard for that as well, which if you click on your selected host and you want to select Homelab in this case, you can see that I can pick any of my containers and I get some nice stats about their memory usage, disk usage, etc. Now, this is quite bare bones and you'll have seen some amazing looking Homelab dashboards out there. I'm giving you the tools and showing you how to do this so that you can go away and build something similar. Also, and we'll cover this in the next video, there's a whole host of dashboards that are publicly available on the Grafana website, provided that you feed it the data that it expects. So thanks for sticking with me guys on this video. I know there's been a lot to take in, but hopefully by the end of this video, you're now able to go and deploy all of the tools that you need to start logging and monitoring. As I said, in the next video, I'm going to show you how to actually configure these tools so that we can scrape many of the things that we're running in our home lab. That will include monitoring our Docker environment, things like CrowdSec, and I'll even show you how to plug it into things like your firewall so that you can monitor all of that traffic. But it's really about giving you guys the building blocks, and I'd love to see what you have in mind. So drop me a note in the comments below. Please like and subscribe if you found this useful, and I'll see you in the next video. Take care, everybody.